All right, good morning. So today we are today's tutorial is on built-in functions and function codes, okay? So I believe it's in the tutorial link. Let me open up something. I think it's tutorial 3 and let's see, tutorial 12, okay? So I'm kind of combining those two. All right, so let's go ahead and open up Matlab. So I got Matlab open here. And let's go ahead and I'm going to copy this. And let's make a new script. File new, pull this straight up, paste. Okay, so I've already kind of had it pre-established. So built-in functions. This script explains different built-in functions. We'll change this to soon you can again. And again, we have some stuff here. Okay. Main code, CLC, clear all, close all. If you remember, CLC clears the command window, clear all clears your workspace, and close all closes all figures. All right, so, and these are just some. There's tons, there's more, but right now I just want to show you some of the ones that you'll probably use more frequent than others. Okay, so comment a, let's talk about square roots. Okay, so x is 100, and you can actually, a built-in function in Matlab is Sqrt of x. Okay, so that's the same thing as taking the square root of 100. All right, so I'm going to dock this. Go up here, dock, scroll down, click a few, and I'll run it. Now, when I run it, I didn't save it yet, but I'm just going to put it and call it Untitled. Let's call it built. I'm going to change into the downloads folder where I saved this file and then go ahead and run it. Okay. So the answer is 10. All right. So very simple built-in function. Okay. Let's look at some trig. So we have theta equals 45. And then if you want to do radians, we kind of talked about this last tutorial. D equals cosine of theta. R equals sine of theta. And let's call O is equal to tan of theta. Okay. So these answers, D, R, and O, are right here. They're radians of 45 degrees. Okay, or 45 radians. Okay, and so you got radians, and then if you want these to degrees, I'll put semicolons on here so they don't spit to the command window, like we talked about. Degrees, Q, you got to put cos D of theta. Got T is sine D of theta, and Y is tan D of theta. Okay. So this gives you the answers in terms of degrees. Okay. Or if you have, sorry, correct. If you have your angle in degrees. Okay. So, and again, just to show you like radians and degree differences. That's all I'm kind of showing you here. Okay. All right. So cool. All right. Well, let's look at the inverse. Okay. If you want to find the angle, okay, like that of a triangle. So opposite is 4, adjacent is 3, and the hypotenuse hypotenuse, sorry, is 5, okay? So we're going to define a variable called th cosine. And this is a cos d of adjacent divided by hypotenuse. Okay. So here you have basically a triangle, okay, a 3, 4, 5 triangle. And you're kind of looking at how to find the angle, cosine angle, th, would equal to adjacent over hypotenuse. Okay. So again, you're looking at a triangle. You got 3, 4, 5. Okay. 3, 4, 5. So you have that type of triangle. And here you're looking for the angle, basically that's the adjacent, okay, which is down here, to the hypotenuse. So right here, this angle, okay. That's how you do it. You put a cos d, okay, because we want to figure it out in degrees, okay. So this is in degrees. Now, if we want to find the sine of that angle, whoops, you do a sine d of opposite over hypotenuse. This is sine of theta equals opposite over hypotenuse. Okay. And then if you want to find th tan, the angle tan d of opposite over adjacent. Okay. This would be tan theta equals opposite over adjacent. Okay. So here the last one is you have 3 and then you got 4. Again, you're still looking for this one, this angle theta, but it's opposite over adjacent. Okay. So if you're looking to figure out the inverse, all right, to try to find the angle, to specifically when we do trig, when we find triangles, okay, you just put the a in front. Okay. Cool. In degrees. In degrees. So Matlab, again, has these built-in functions to find cosine, to find sine, tangent, and radians or degrees. Or if you're looking for the angle, when you're doing a triangle or whatever, you're doing trig, you can just do a cos d or a sine d. Okay. All right. Okay. Let's do nested functions. You can put a function inside a function. Okay. So for example, gh equals square root of sine d of theta. Okay. And I'll run this. And again, I didn't show you this, but over here you can figure out these angles, right? These should be all the same, 53, 53, 53, because we're referencing the same location in that triangle, okay? And then here what I did is I just took the square root of sine of theta, just to show you that you can do a function inside a function, okay? Let's see, what else we got? I guess we called this C. This would be D. This would be a natural log. So if you're trying to find the natural log, you actually got to use log of x, okay? So if I put a semicolon here, run it, this is, if you remember all the way to the top, x was 100. So we're looking for the natural log of 100. Okay, if you put that in your calculator, you do have ln, but Matlab just uses log for natural log. Okay, so make sure you're aware of that. Okay, E, this one's log based 10. Here you would do like log 10 of 10 or something. Okay, so run this again. You get 1. Okay, so this is again the log based of 10. Okay. So I know you got logs and natural logs, but just make sure in Matlab you use log for natural log. Okay. Some rounding things that you may need. Let's say Z is 8.6, and then let's call it L is round of Z. So you can use this built-in function called round, and this will round up depending on your number. So if it's say 8.2, it'll round down to 8. Okay. If it's 8.5, right, it should go up. If it's 8.4, it should go down. Okay. Cool. What else we got here? Complex numbers. You can also do this. You can say 5 plus 3i. P equals 2 plus 2i. And I take the semicolons out to show you. Okay. Some of you may be in some sort of class or doing something where you need imaginary numbers. Okay. And Matlab can do that. Okay. So complex imaginary numbers. Pretty cool. And the last thing I want to show you in this are statistics. So stats. Okay. So X equals 100. We're going to make a matrix. 90, 85, 75. So you got 1, 2, 3, 4, 5 exams, and this is what your grades were. Okay. And if you remember, if we run this, X, we have a matrix, and these are our rows, right? So row 1, row 2, row 3, row 4, row 5. Okay. Okay, cool. Now, we can find the average by just saying mean of X. Okay, run it. The average is a 90. Okay, so if you added all these up and divided by 5, you would get 90. Okay. What else? We got the mean and the mode. The mode, the mean, and the max. So, mode, what is the one that frequently shows up? You just type mode of X, run it again, and 100. Okay. How about the min value? Well, B, we'll say min of X. This should be 75. And then the max you should see is 100. Okay. So these are just a few of the built-in functions that you use. Typically, you're going to be using square root a lot, maybe the statistics a lot. But a lot of the times it's cosine or sine. Okay. And students do forget to put D in there if they're doing degrees. Okay. All right. And again, there's more, but I just wanted to give you a brief introduction in this. Cool. All right. Next, I want to combine that with function codes. Okay. Because they're you can make your own function code. Okay. So I'm going to make a new script. So I pasted my header format. This one's functions. Okay. I made this example code, and you'll see this in a tutorial in February 2013. Okay, that's kind of crazy. We'll look at functions and global variables. Okay, cool. So here's my main code. I'm going to start with all that. Now, what we want to do is I'm going to copy and paste this, and I'm going to go through it. Okay, so we're going to build our own function code. Okay, and I'll show you where we do that. Okay, so the format for these is pretty much you have an output, okay, that you're going to get from that script. You got your function name and whatever input. Okay, so this is just a very simple example that I'm going to show you and then we'll do another one, okay? So we will build a function to find the answer for this polynomial right here, okay? If we plug in x of 10, right? We could just make an equation right here and just say y equals and just put all that in there, right? Okay. However, I want to make sure you understand that two things, how to make function codes and what they are. These function codes that you'll see here are extra scripts that you can write and make your code to make your main code shorter. And if you're going to use that code a lot, then you can have that in multiple scripts. Okay, for example, like the quadratic equation, you can just have a function code that you call in your code, and then boom, you can find a quadratic of it, and we'll do that. Okay, so output, and then we're going to make a function called basically poly. Okay, and we're going to, so basically if you look here, this is our output. This is the function name, and then this is the input. So we're going to input x, which is 10, and we're going to make a script that does this. Okay, so let me go ahead and grab this. So what you're going to do is first, I'm going to save this. I'm going to call this function code. Then what you're going to do is you're going to go up to new, click the arrow, and you're going to do function. Click that. Okay. Now, here, what you're going to do is you got to leave the blue, the function, and end. So leave that. Over here, okay, what I want to do is I want to call this output. Let's go up here and just call this output. Okay. This is our function name, which we called it poly. And then this is our input, which is x. Okay. So if you notice, this is pretty much the same as this. Okay. Because that's how you make function codes. Now, this is our function name. That has to be what it's called. So when you save it, if you type it in here, it has to be called poly, otherwise it will not work. And it has to be in the same folder where your main code is. Okay, so it is. My function code's in my downloads, so I'm going to save. Okay. So now I have a function code. I can delete this. And in between the blue, the function and the end, this is where you put output equals the polynomial 3 times x cubed plus 6 times x squared plus 2 times x plus 10. Okay. Again, we could have just put this in the main code, but I wanted to show you how to do functions because we're going to do the quadratic equation, which you can use in multiple codes. Okay, especially we use a quadratic a lot when you're doing dynamics. You're looking at conservation of energy with springs, and almost every problem you need the quadratic equation pretty much. So if you're making a code, you can just make a function code that's called quadratic, and in all of your main codes, just call that function. Okay. Now, anytime you see the star here, you want to make sure you save it. So click save. Okay. So now you've just created your own function code. Okay. Go back into your main code, and we can now go ahead and run it. Okay. One thing that I haven't really mentioned is, you see now with this main code, there's a star. That means I need to save it. Anytime you click run, it'll save first, and then it'll run it. So you never have to click save. Okay. So basically what happened was we jumped to this script, this .m file, which is called poly, and it ran down line by line, and it ran this. Okay. And what it did is it spit out this output, which is the output here. Okay. Now we don't have to call this output. We can call this whatever, but I like to call it output. So hopefully you can understand what's going on. Okay. So if we change this to like 23, run it, boom, we get the answer. Okay. And again, we could have just put this equation into here, but I wanted to show you again how functions are made. Very simple, crude. Okay. Again, with function codes, you got, when you type it, just go to File, New, keep function, have a space. These are your outputs. So to the left of the equal sign. Okay. This is the name of the function code that you're calling, which is your main, in your main code, which you're calling here, where you're calling poly, which is this script. So when you save this function code, it has to be called that, and it has to be in the same folder as this. This is what you're bringing into this function code, which is X. And then you go ahead and execute all of these commands, okay? And back in your main code, it'll spit out what that output is. Pretty cool, okay? So, close that. Let's look at quadratic equation, okay? Because quadratic equations are used a lot. So, number 2, quadratic function. Say we have x squared plus 5x plus 6 equal to 0, and we want to find x. Okay, what is the formula? Okay, well, we know that it's negative b plus or minus square root of b squared minus 4ac over 2a, if I remember right. Okay, okay, so if you remember the quadratic equation, whatever's in front of your x squared term, okay, it's a, so it's really a, and I can put this here so you can see it. It's a, right, times x squared plus b times x plus c, right, equals 0. So that's why I defined a as 1, b is 5, and c is 6. Okay. And so, you know, there's going to be 2 answers. You've done the quadratic before, you know there's 2 answers. So these are my outputs that are going to be in my function. Answer 1, answer 2, and then here is the function code that I'm going to make. I'm going to call it quadratic. And these are my inputs, A, B, and C. Okay. So I'm going to go ahead and save this. Get rid of poly. Go to new, function code. Okay, and let's do the quadratic. Let me have this open. And I don't want you to, whoops. Undock, there we go. Sneak peek before we do it. All right, so here's the function. This one's going to be answer 1. This is going to be answer 2. This is our name of our function. So quadratic, so quadratic. And these are our inputs into the function, A, B, C. Get rid of this. And I'll get rid of these. Okay, so answer 1 equals, let's see. So parentheses minus b plus square root of b squared minus 4 times a times c, close, close, divided by 2 times a. And if you don't know the quadratic equation, you can look that up, okay? So it's minus b plus or minus the square root b squared minus 4ac all over 2a, okay? Now, this is the plus term. Answer 2, you put the negative here, right? So plus negative b plus or minus square root of b squared minus 4ac over 2a, okay? And we got to call this answer 2, okay? So So we've now built the function code. Again, just to reiterate, we got function. These are our outputs. So these are the left of the equal sign. And then we have to name it. So we have to save it. So let me click Save As. And look, it's already named quadratic because we automatically put in there. It's in the same code as our main code. Click Save. And now there's no star here, so it's saved. These are input that we're putting in from the main code, which are on the right side of the equal sign. And then here's where the equations are. Okay. So if we go back to the main code, we can now, I'm going to suppress this so it spits to the command window, and we can run it. Okay. So when we run this, we get two answers, -2 and -3. Okay. So let's just check. And you know what? I'll do it right in the command. I'll do it in the command window. You don't have to. So -2 squared plus 5 times -2 plus 6. You get 0. Okay. Now I hit up and I can just change these to -3, -3, 0. Good. So that I always do that to make sure that my equations or whatever I put in there actually does make sense. Okay. So again, if you want, do it in command window, or you can make your code just to check. Again, CLC will clear all. We can run it. Okay. Pretty cool. So what else we got here? We could do global variables. Let's do global variables real quick. Okay. Oh, and you know what? Let's make this, sure. Let's just quickly do something. I'm going to copy and paste this in. It's going to be quite a bit, okay? But bear with me for a second, okay? Go right up to the top here. We're going to do an engineering problem, and we'll make a global variable with this, okay? So say the acceleration is 0.5 t. We want to write a function that will calculate a, v, and did I call it d or did I call it s? Oh, let's call it s. So we're looking for acceleration, velocity, and position, okay, for an array of time values. Okay, we won't do this. I'll just give you the equations, okay? That's just a practice. So here's our initial velocity, our initial location, initial time, final time, and our time increment, okay? So these are our givens, okay? And if you remember, I like to put things like this. Okay, so these are the things that we could change. And here is our time matrix. So some of this is review from last tutorial. And then here is our function code. Okay, A, B, S. These are our outputs. These are what we're finding. This is the function code called motion. This is the initial velocity, initial position, initial time, and our time matrix. Okay. Then what I did is I created, and I'll get rid of these double comments. Okay. I basically created subplots, 3 subplots. Okay. With basically acceleration, velocity, and position. Okay. Again, we've talked about subplots the last tutorial, so you can take a look at that. All right. But again, here are these code, these if you want to write them down and try it on your own. All right. So let me save, get rid of quadratic, and I'm going to just open up my motion function code. And I'm going to save it in downloads where my main code is. Okay. downloads motion. Okay, so get rid of these. You don't need those, and you don't need that. That's fine. Okay, so actually, I'd rather do that. Find the code on the fly. Okay, cool. So here are the equations, the three equations to find acceleration, velocity, and position. Okay, now don't worry if you don't know how to find those. That's not the point here. What I'm trying to show you is we're creating a function code, and then I want to get it to work, and then I'll show you what a global variable is. Okay, so here's the acceleration term. Okay, and if you remember, V naught, S naught, and T naught are just one value, but T is a matrix. So these input arguments can be anything. They could be a number, they could be maybe a character, which we haven't talked about. They could be an array or a matrix. Okay. So here, if you remember, because we're multiplying by time, which is a matrix, I always put the dot in there. We talked about that yesterday. Okay. Now you don't really need it if you're multiplying it by a constant, but you will when you're taking t squared, right? Okay. So this is your velocity equation. Here you have initial velocity, initial time in here. Here is position, this equation right here. Okay. And wherever I had t, I had to make sure to put the dots here. Okay, dot. Okay. These are all constant, v naught, t naught, and so forth. Okay. So here is our function code that calculates the equations for acceleration, velocity, and position. There's a star here. Make sure we save it. Go back to our main code and let's run this. Okay. And I'm going to CLC clear all. Go ahead and run this. So this should calculate everything that we need, and it makes a subplot, and I'll blow this up so you can see it. So we have acceleration, velocity, distance, or position. It's okay. So titles, okay, and then I've changed these so it's blue, red, and black. Okay. And just a quick comment. See how this is linear? This will then be a curve, and this will be more of a curve. Okay. So first order, second order, third order. So these are just looking at graphs that find acceleration, velocity, and position of a car as a function of time. So that's pretty cool. We just created a function code that has these three equations, and we can do that. Okay. What I'm going to do now is show you a global variable. Okay. And I'm going to delete everything up to here. Okay, and we're going to say global, and let's just put 1. Let's do v naught. Okay. So global variables are variables that are used in certain locations or multiple function codes. Okay. So here's my main code. I defined what variable I want to make it global, which I'll then use in my motion code. Okay. So I've defined what this value is. Okay. Which is 0. Okay. We're going to change this here in a minute. Okay. Down here though, I don't want to put it in my function code because it's a global. Okay. So what you got to do is make sure that you delete it in here too. Okay. And define it right here, v naught. Okay. Now if you, I saved it. So now if you notice, see how this is like a light teal or a teal color now? Because this variable is now shared and this variable. So that's what they're called, global variables. So you define this in your main code, and then you make sure you put that into your function codes. That's pretty cool. Okay. So again, what I ended up doing was on line 35 here, I deleted v0 because I just want to make that a global variable. Okay. So I typed it in global variable underneath close all. I define what this value is. Okay. And then over here, I typed in global v0, and then that actually changes everything. Okay. So now if we run this, all right, we still have this value. If we change this to like 5, we run it. Okay. And let's zoom in here. Look, it changed it to 5. Okay. So the velocity started at 5 now. Okay. Pretty cool. Let's not, let's see, let's go to like, I don't know, 5 seconds. Probably can see it. Yeah, see how it starts at 5 now? Okay, I don't know, let's say 0.1. And then it should start at 0.1 if we zoom in here. Yep, all right. So global variables are pretty cool because you define what they are. In your main code, define the value, but any other codes or function codes that you're going to use, just type in global v0 and it will automatically change that number for you. Okay. So I could have done it with s0 and t0 and just inputted t, right? So if I want to do that, I could do s0, t0 down here, delete those, save it, go to motion, type in s0, t0, get rid of this, save it, okay, and then run it again. And you should get the same thing, okay? So I don't know, let's say that starts at 40 and run it. Okay, boom. So pretty cool. Pretty cool. Let me minimize this. So let's recap this tutorial. So what we ended up doing first was just quickly talking about some basic built-in functions that Matlab has. Square root, cosines, sines. And depending on what you're doing in radians or degrees, make sure you put the D in for degrees. If you want to find the inverse of the angle, like using trig on a triangle to find the angles, make sure you do A cos D or A cos, depending on your radian term. Okay. Natural log is log. Log base 10 is log 10. You can round, you can have complex numbers, and a lot of the times you do mean, mode, and min or max. Okay. We then talked about function codes, okay, where you have a main code where you write your script, but then you build a function code where you don't have to put the equations you're using in the main code. You put it in your function code because it does minimize your main code lines. And for example, we did the quadratic, and that's used a lot of the times in different problems. So we can just make a function code called quadratic, and we can just run that code or call that code when we need to. Okay. And then with function codes, you write function. These are your outputs. This is your function name. Make sure it's saved as that in the main code. Make sure that's in the same folder as your main code. And here's your inputs. Always remember outputs are on the left of the equal sign, A, V, and S. And your inputs are on the right side of the equal sign in your function code. Okay. We also talked about global variables. So here in your main code, you define them and you give them a value. But then in your function codes, all you have to do is say global V naught, S naught, and T naught, or whatever you have, and these will update automatically. Okay. All right, I hope you enjoyed, and I will see you in the next one.